one of the two rows is non-zero. Then what will happen if suppose first row is non-zero, then what will happen? Pi 1 1 yt minus 1 plus pi 1 2 yt minus 1, sorry यहाँ पे x होगा, xt minus 1 and yt minus 1. This should be I0. यानी x is I1, y is I1, then you have pi 1 1 time xt minus 1, pi 1 2 time yt minus 1, and which is equal to I0. This means this is equal to the definition of co-integration. Co-integration यही चीज़ थी ना. You have two I1 series and then you have a weighted sum of the two series, which is turning out to be I0. And if this happens, then there is co-integration. So the null hypothesis of co-integration turns out into this format. This becomes the null hypothesis. H naught pi is equal to 0 and H1 pi is not equal to 0. Okay. This is equivalent to no co-integration. Null is no co-integration. But if you have non-zero terms, then the definition of co-integration applies, and you will have co-integration. So the test for the co-integration turns out into the test for pi equals 0 versus pi is not equal to 0. You might have listened some terminology in your FSC, rank of a matrix. What is rank of a matrix? Rank. No. Number of non-zero rows in the echelon form of a matrix. Is it so? Number of non-zero rows. So, you can say that if this is not equal to 0, then at least one of the rows in this matrix must be non-zero. If one of the rows is non-zero, then you can say rank of pi should be greater than 0. Okay. This is your alternative hypothesis which will lead to co-integration. And the null hypothesis is rank of pi equal to 0. What is rank? Rank is the number of non-zero rows in the echelon form of a matrix. Echelon form क्या है? You can revise it from your FSC, but we are not going into further detail. Simply you can say number of non-zero rows, number of linearly independent non-zero rows. Is it okay? So the test for co-integration becomes rank of pi equals 0 versus rank of pi is non-equal to 0. And if you have 3 by 3 matrix, then the rank could be 1 or 2. 0, 1, 2, these are 3 possibilities. If the rank is 0, then there is no co-integration. But if rank is 1 or 2, then you have co-integration. And suppose there are n variables in the relationship, then the rank may go up to n. Right? But what happens, it is being said that you cannot have full rank matrix. If you have 4 variables, the number of non-zero rows is also equal to number of co-integrating relationships. How many co-integrating vectors exist? This depends on the rank of matrix. But if you have n variable in the relationship, the rank may go up to n minus 1. If rank is also equal to n, that means all the variables are stationary, which is contradictory to our assumption that x and y are unit root. So you may have, in order to have co-integration, the rank should be greater than 0 and less than n, right? So now there is a sophisticated mathematics behind all of these things. Can I take a call, please? There is a sophisticated mathematics behind all of these things, and you might have listened to the term trace test, eigenvalue test, and so on. All of these things are related to BS level mathematics on matrix algebra, and if you are interested, maybe Mia Ghulam Ghosh will teach you this kind of course, but this is, look, our target is the practitioners, and for practice you don't need to know all the details. For example, you can drive the car without knowing how many chambers are there in the car and how many cc is the engine and so and so. You can drive the car without having all these things. So those who are learning economics, basically they are driving, they are at the driving position. They should learn how to apply these tests without worrying about what the background is. But if someone wants to know about the engineering, Mia Ghulam Ghosh can do this thing for you. Okay, so now we will go to the computer and we'll show you how to apply this VAR model and co-integration analysis. ये मल्टीमीडिया ऑन कर दीजिएगा. इसका पासवर्ड लगाइएगा. कौन सा सॉफ्टवेयर यूज़ करें? So this is the data that we have used yesterday. The basic variables are consumption and GDP, and we have taken the log transform in order to smooth the series. And now I want to construct a VAR model. I am selecting this L consumption and L GDP. I can open these as var models basically. Open as vector autoregressive. Right? This time it is asking for having two legs in it. You can choose these two legs. Let me proceed further. This is your var model. What does this mean? What is this thing? Basically L cones is equal to 0.87 the first column is the equation for consumption and the second column is equation for GDP. Right? So you can write a var kind of model out of this in the matrix format as well. Basically the first column will give you first row actually which I have written. The coefficient that were appearing in the first row would be available to you in this format in the first column. Now the question is, how many legs of var should we have? So you can basically ask this